Hi all, we will start the session with one more round of problems and solutions from chapter number 2, that is atomic structure, from NCERT part 1, class 11. So I'll just share the for the NCERT class 11. So now you can see the PDF here. So we move on to the question number 2.3, that is how many neutrons and protons are there in the following nuclei. Now you can see here, that is 8 carbon 13, 8 oxygen 16, 12 magnesium 24, 28 iron 56, and 38 strontium 88. What we need to do is we have to find out the number of protons, neutrons that are there in each case. So let us look into the this one and try to find out the solution for this. You have to find out the neutrons as well as the protons. So now immediately I'll stop share the PDF and just will move on to the frame wherein we share the whiteboard so that it would be convenient to discuss the problem. So now I'll start this solution for this problem. So you are supposed to find out the number of neutrons and also number of protons for the following atoms. First one is your C12. Second one is your 8 oxygen 16. And third one is your 28 iron 56. Then of course also you have this magnesium, 12 magnesium 24, and then strontium 38 atomic number, and 58 is the mass number. So when I write the symbol of any particular element this way, 6 as a subscript and 12 as a superscript, the superscript denotes mass number A. Mass number is represented by A. Superscript denotes mass number, and the subscript denotes the atomic number. So this we have the symbol as Z. It is atomic number. So you know atomic number is nothing but it is the number of protons or the number of neutrons that are present. Number of protons or number of electrons present in a given atom. So therefore, when you sum up the protons and neutrons in the nucleus, you'll get the mass number. Why? Because these are the two constituent particles, that is your protons and the neutrons. These two things, number of neutrons plus number of protons, these two things will give you the mass number A. So therefore, suppose if you indicate the number of protons as Z and the number of neutrons as N and the mass number as A, so Z plus N is equal to A. So in order to find out the number of protons, you have to look into the subscript number, that is Z. So therefore, once you know the protons, you subtract the proton number from the mass number so that you can get the number of neutrons. So let us see, in the case of carbon, Z minus A, what would be in the case of carbon? In the case of carbon, A minus Z, 12 minus 6. For carbon, it is 12 minus 6, that is equal to 6. So the number of neutrons is 6 in the case of carbon, mass number is 12, proton numbers are Z or atomic number is Z. So similarly for the oxygen, if you take 16 is the mass number and the atomic number, you know, 8. So therefore 16 minus. So let us see the next one. So this time again we'll share the PDF. We'll move on to the next problem. The next problem will be find the energy of each of the photons. So you have to find out the energy of the photons, whose frequency is 3 into 10 to the power of 15 Hz and the wavelength is 0.5 angstrom units. Two different photons are given here. Each one has been given a particular value. The first one is the frequency 3 into 10 to the power of 15 Hz and second one is 0.50 angstrom units, that is wavelength. So we'll just highlight the text and then we'll move on to the board. Now what we do is we'll stop sharing this PDF and then we'll move on to the board. So whiteboard. So now the frequency is given. The frequency value is given as 3 into 10 to the power of 15 hertz. 3 into 10 to the power of 15 hertz. That is the frequency. And then what is that? We have to find out energy of this photon. Energy of the photon, according to the Planck's quantum theory, if you apply the formula, E is equal to h nu. E is equal to h nu. H is the Planck's constant and nu is the frequency of the radiation. So therefore, h value is a constant, which we will write it as 6.627 into 10 to the power of minus 34 joules per second, joule second, multiplied by the frequency value 3 into 10 to the power of 15. So the Planck's constant multiplied by the frequency of radiation will give you the energy here. So 6.627 into 3. So let us look into the numericals of this. 3 sevens are 21. Yeah, we'll write it out. 6.627 into 3. That gives you roughly 19.88. So you'll write it as 19.88 multiplied by 10 to the power of minus 34 and 15. That gives you 10 to the power of minus 19. Since energy is measured in joules, you'll write it as 19.88 into 10 to the power of minus 19 joules. And then what is the other value that is given? The next thing is they have also given the angstrom units. So angstrom units, in the sense, this is the wavelength they are talking about. So therefore, they have given the lambda value. The lambda value for the photon. The lambda value for the photon is given as 0.5 angstrom units. The lambda value is 0.5 angstrom units. So that is written as 0.5 into 10 to the power of minus 8 centimeters. 10 to the power of minus 8 centimeters is your angstrom unit. So 10 to the power of minus 8 centimeters. So if you want to convert that into the meters, so what you have to do? 0.5 into 10 to the power of minus 8 into 10 to the power of minus 8. 1 centimeter is equal to 10 to the power of minus 2 meters. So there, in the place of centimeter, you will be writing it as 10 to the power of minus 2. So put together, that would become how much? 0.5 multiplied by 10 to the power of minus 10 meters. So since you know this one, now what is that you have to find out from this? You have to find out the energy. So energy, according to the Planck's constant, as already we have discussed the formula, E is equal to h nu. So that can be written as E is equal to hc by lambda. Hc by lambda. Why? Because nu is equal to, since nu is equal to c by lambda. Already we have discussed about this particular relationship. C is equal to nu lambda, therefore nu becomes c by lambda. So in the place of nu, you'll be writing c by lambda. In the place of h, you'll be writing the Planck's constant as usual, 6.627 multiplied by 10 to the power of minus 34 multiplied by c value 3 into 10 to the power of 8 meters per second divided by value of wavelength 0.5 multiplied by 10 to the power of minus 10. So this is that. So now what you do is, as usual, you can 0.5, in the sense you can take it as, you can take the numerator, you can take it as 2. So therefore it would become, we can go by the approximation. So therefore we can write it as 6.627 multiplied by this 0.5. I'll write 2 in the numerator. Why? Because this is 1 by 2. in the denominator, that becomes automatically how much? 2. So therefore, suppose if you write 6.627 multiplied by 3 multiplied by 2, then you have 10 to the power of minus 34, 10 to the power of 8 and 10 to the power of 10. Minus 34 and 18. That will become how much? 16. So I can write here as 10 to the power of minus 16. So that gives you how much? 2 3s are 6. So therefore you can multiply the entire thing with the 6. You'll get 6 7s are 42, 6 2s are 12 plus 4, 16, 6 6 are 36 plus 1, 37, and 6 6 are 36 plus 3, 9. So therefore you will get a 39.762 multiplied by 10 to the power of minus 16. Now what we will do is we will convert that into a significant number. This value 39.762 will convert that into a significant number. How will you convert that? 39.762 multiplied by 10 to the power of minus 16. So you should write it in the form of 3.9762. So 3.9762. So therefore you have to shift the decimal to the left hand side. So it is getting decreased. So multiplied by 10 to the power of minus 16. So you have to shift it to the left hand side. What you have to do? You have to reduce it. In the sense you should divide it. So as to compensate that, you have to multiply with another 10. So another 10 in the sense like 3.9762. If you have to write like this, that becomes what? 3.9762 minus 16 divided by, so 3.9 you are writing, divided by 10. 39.762 divided by 10 will become 3.9. So therefore, when you're writing 3.9762, you have to multiply it with 10. So therefore, that becomes how much? 3.9762 multiplied by 10 to the power of minus 15. So this is how we will solve the problem. And then now what we have to do is, then we'll move on to the next one. Next problem is like, we'll share it from the PDF. Calculate the wavelength, frequency, and wave number of a light whose period is 2.2 into 10 to the power of minus 10, 10 to the power of minus 10 seconds is 2 into 10 to the power of minus 10 seconds. So therefore, so period value is given here. So if period value is given, how to find out nu, lambda, and nu bar? Nu, lambda, and nu bar. Let us try to understand the question. So I'll add on one more board here. So the problem is like this. You have been given the period. Period is indicated by T. That is 2 into 10 to the power of minus 10. So that is the time period. So what is that you have to find out? You have to find out the nu, that is frequency. Also you have to find out the wavelength. Also you have to find out the nu bar. So nu, let us find out first one. Nu is equal to 1 by T. That is equal to, we can write it as 1 by 2 into 10 to the power of minus 10. So that becomes how much? 1 by 2 is 0.5. You write it as 0.5 multiplied by 10 to the power of 10. 10 to the power of 10. So that you can write it as 5 into 10 to the power of So you made it, you're multiplying it with the 10, so you have to divide it by the 10 so as to maintain the value. So it becomes 5 into 10 to the power of 9h. 5 to 10 to the power of 9h, that will become the new value. So once you know the new value, lambda easily you can find out. That is from the formula C is equal to nu lambda. You can find out lambda is equal to C by nu. Lambda is equal to C by nu. That becomes how much? 5 multiplied by 10 to the power of 9 is the value of the frequency. So what we do is we'll write the value of C here first. C value will become out how much? 3 into 10 to the power of 8 meters per second divided by the frequency value 5 multiplied by 10 to the power of 9h. So that becomes 0.6 multiplied by 10 to the power of 8 minus 9, that will become minus 1. 10 to the power of minus 9 plus 8. So therefore that is 0.6 into 10 to the power of minus 1 meters. So if it is 0.6 into 10 to the power of minus 1 meters, so in order to write it down in the scientific notation, you have to multiply with 10. So therefore by 10, so therefore it is 6. So it becomes how much? It becomes your 6 meters. 6 into 10 to the power of minus 2. 6 multiplied by 10 to the power of minus 2 meters. So therefore this is how you'll write the value of lambda. So nu bar, as you know, the nu bar is nothing but a wave number. Nu bar is the reciprocal of the wavelength. So that is 1 by 6 into 10 to the power of minus 2. So that becomes how much? It becomes 1 by 6 into 10 to the power of minus 2 is 1 by 6 multiplied by 10 to the power of 2. So that becomes 0.1 6 into 10 to the power of 2. So that becomes 1.66 multiplied by 10 to the power of into 10. 1.66 into 10. So this will be the nu bar or the wave number value. So this is how we can find out the frequency as well as wavelength as well as wave number from the time period that is given. So now we'll stop sharing this one. Again, we'll move on to the next slide. That is what is the number of photons of light with a wavelength of 4,000 picometers that provide 1 joule of energy. This is another interesting problem. You have to do this one. Okay. 4,000 picometers is the wavelength of the photons of number of photons of light with a wavelength of 4,000 picometers that provide 1 joule of energy. So that is what we have to do. Number of photons of wavelength 4,000 picometers that can produce 1 joule of energy. Okay. So let us see. Adding the whiteboard here. So now let us look into this. Number of protons. Number of photons. Photons are the constituent particles of the light. So with wavelength 4,000 picometers. 4,000 picometers is nothing but, right here, 4,000 picometers is equal to 4,000 multiplied by 10 to the power of minus 12 meters. 1 picometer is equal to 10 to the power of minus 12 meters. So therefore, you know you have to find out the number of photons of wavelength 4000 picometers required to produce an energy of 1 joule. So you have to find out the number of photons of wavelength 4000 picometers that would generate the energy of 1 joule. So you know the formula for the Planck's constant, E is equal to NH nu when there are n number of photons. So when there is 1 photon, it is E is equal to h nu. When there are n number of photons, you write it as E is equal to NH nu. So you have to find out this n value. Already we know the E value. E value is given as 1 joule. E value is given as 1 joule. And also we know the wavelength. So wavelength, if you know, from C by lambda, we can write down this one. So therefore, this can be written as 1 is equal to, 1 is 1 joule, that is energy. This N we do not know, multiplied by H. H is Planck's constant, anyway, we'll substitute that. H C by lambda, because nu is equal to C by lambda. Since nu is equal to C by lambda. So now what you have to do from this, you have to find out the n value. So what we have to do is, we'll take this HC lambda to the other side, so that n becomes lambda by HC. Lambda by HC. So lambda value already they have given, that is 4000 picometers. That becomes how much? 4 into 10 to the power of 3 into 10 to the power of minus 12. That is 4 into 10 to the power of minus 9 meters multiplied by 3 into 10 to the power of 8 meters per second divided by, sorry, this C value you need not write in the numerator, that part of it will take it off. That you have to in fact write in the denominator. So in the numerator you have to write only lambda value, that is already given. Lambda is 4 into 10 to the power of minus 9 meters. And then H value, you know, H value is 6. I'll brief it as 6.63 into 10 to the power of minus 34 multiplied by 3 into 10 to the power of 8. C value is 3 into 10 to the power of 8. So that becomes how much? 4 multiplied by 10 to the power of minus 9. So we'll take all these 10 exponential forms in the numerator. So 10 to the power of minus 34 into 10 to the power of 8 will become 10 to the power of minus 26. That I'm writing in the numerator. And in the denominator, what are the numericals that are left over? 6.63 multiplied by 3. So this is all left at the end. So that becomes how much? 4 multiplied by 10 to the power of minus 9 into 10 to the power of minus 26. So these two things put together, it will become your minus 26 in the denominator. When it comes to the numerator, you need not write the minus value here. You can do away with this, because in the denominator you have 10 to the power of minus 36. When it comes to the numerator, it becomes 10 to the power of 26. So therefore you can write here 4 multiplied by 10 to the power of minus 9 into 10 to the power of 26. That becomes 10 to the power of 17 divided by 6.63 into 3. So 3 3s are 9. 3 6 are 18. 3 6 are 18 plus 1, 19. So 19.9. So you can take it as 4 by 20 roughly. So that is 1 by 5. In the sense, it becomes how much? 0.2 into 10 to the power of 17. Or you can write it as 2 multiplied by 10 to the power of 16. So 2 multiplied by 10 to the power of 16. This many photons are required in order to produce 1 joule of energy. So what is the other part of the problem? The other part of the problem is you have to find out the wave number of the light. So once you know the frequency, you can easily find out what is the wave, what is the wavelength, wave number also. So once you know the hc by lambda, wavelength we have already taken. So the reciprocal of the wavelength will become what? That will become your wave number. So wave number, nu bar, I'm writing here, nu bar is equal to 1 by lambda. Already we know what is lambda value. That is 1 by 4 multiplied by 10 to the power of minus 9. So that becomes what? 1 by 4 is 0.25 multiplied by 10 to the power of 9. 0.25 multiplied by 10 to the power of 9, because it's 10 to the power of minus 9. When it comes to the numerator, it becomes 10 to the power of 9. 1 by 4 is 0.25. So therefore, we can write this as 2.5 multiplied by 10 to the power of. So you are taking it to the right hand side, you're increasing the value. So if you have to write this 2.5 in the terms of 2.5, you're increasing it by 10. So therefore you have to reduce it by 10 in the exponent. So it becomes what? 2.5 into 10 to the power of 8. So that will be the formula for the wave number. So therefore this is how we can find out the number of photons with a particular wavelength. How many numbers of photons are required in order to generate the 1 joule of energy. So therefore that is how many? 2 into 10 to the power of 16. So this is the formula that we will use. So for today's session, we'll stop it here. In the next session, we'll continue from the next problem articles. Thank you very much. Keep watching the channel, subscribe and like, and continue to watch this so as to see the further useful things like your NEET material as well as JEE Advanced, which is to be followed later in the coming videos. Thank you all.